Good day, everyone. I'm Ana Quiros.
And I'm Quiros Urbano, and we're here to discuss a problem on first-order ODPs. To solve this problem, let us first name our variables. Let x represent the amount of money in the bank, t for the length of time that the money is in the bank. Reading the problem might help us establish the important details needed in this problem. In the first sentence, it is implied that the initial amount of money in the bank is 100,000 pesos. That means that at t is equal to 0, x is equals to 100,000. Then, we are asked to find x at t is equal to 5 years. Also, we are told that it was a 7% continuous compound interest. Let us first explain what continuous compound interest is. Suppose this photo of bills represents the principal amount and these gold coins are the earned interest. The concept of continuous compound interest is that once these bills are deposited in the bank, it already earns golden coins. Also, the golden coins are already earning their own golden coins all the same time with the bills. That goes on over an infinitesimal amount of time. If it is said that it is a 7% continuous compound interest, then the money is growing at a rate of 7% instantaneously. The instantaneous rate of growth is denoted by dx over dt and is proportional to the amount of money x. We notice that this is a growth problem. The constant of proportionality would be the interest rate 0.07 and we derive the equation dx over dt is equal to 0.07x. In the next sentence in the problem, it is stated that the net addition to the amount of money in the bank every year is 50,000 pesos due to the withdrawals and deposits of the man. This should not be confused with the bulk deposit of 50,000 pesos at the end of every year. Let's illustrate this to get a clearer understanding. Let the blue arrows represent 25,000 peso deposits. The red arrows are the 25,000 peso withdrawals and the larger blue arrow is a 50,000 peso deposit. The problem states that the 50,000 peso is a net addition for all of the transactions made by the man. Suppose he made 5 25,000 peso deposits and 3 25,000 peso withdrawals in a year. Then that is a net of 50,000 peso deposit. That is not the same as adding 50,000 peso at the end of the year. We need this concept to formulate that x is also changing at a rate shown by dx over dt is equal to 50,000. Now we have two equations for dx over dt. What we do is we add these two expressions because when the net of 50,000 per year is added to the amount in the bank, all of what he has withdrawn or deposited will also earn an interest all the same time with the original amount of money in the bank. The situation with this money in the bank is best illustrated by dx over dt is equal to 0.07x plus 50,000. Now we're ready to solve the problem.
dx over dt equals 0.07x plus 50,000 can be solved in two ways. If we rearrange the equation, we can form a linear or variable separable equation. We can solve either one, but we choose the variable separable equation in this video since the linear one involves a lot of integration and would take a longer time to solve. If we integrate both sides of dx all over 0.07x plus 50,000 equals dt, we get ln of 0.07x plus 50,000 all over 0.07 equals t plus c, and we designate this as equation 1. By isolating c on the left side, we obtain an equation for c in terms of x and t. Then, we can easily substitute the initial condition x equals 100,000 when t equals 0 to solve for c. By doing this, we should get c equals 156.44. We go back to equation 1 and substitute the value of c we got. We then solve for x in terms of t, and then substitute t equals 5 since we are asked for x at t equals 5. We readily solve for x with this substitution and we get x equals 441,233.15. Therefore, the man's money in the bank will be 441,233 pesos and 15 centavos in 5 years.